Hi learners! For today, I will discuss with you about the absolute value in the 4 fundamental operation on integers. And this was based on Mathematics 7, Quarter 1, Module number 3. From LRMDS Bulacan. Thank you and congratulations to the development team of this module. Credits to the author, language reviewer, content editor, illustrator, and layout artist of this module. Hi math lovers! Are you ready? Let's learn! Have fun! Because mathematics is fun! What I need to know. This module provides varied activities that will help you learn more about the absolute value of a number and the 4 fundamental operations on integers. This material will assist you to gain knowledge and skills in solving real-life problems involving the 4 fundamental operations on sign numbers. This lesson includes in this module are the following: 1. Absolute value of a number. 2. Addition of integers, subtraction of integers, multiplication of integers, and division of integers. At the end of this module, you are expected to perform operation on integers, solve simple word problems involving operation on integers, what I know. Now turn your module to pages 3 and 4. Let's answer our pre-test. Choose the letter of the correct answer. Write your answer on a separate sheet of paper. What's in? Number line is a useful tool in comparing positive and negative numbers. This is a number line. Let's try to recall this. How do you compare two integers? Which one is greater? Negative 2 or 2? Positive numbers is always greater in value than the negative numbers. Positive numbers, negative numbers. Positive number is greater than negative numbers. The numbers at the right side of the other is greater than the value at the left side. Here's the number line. 0, all of these are greater. From negative 10, all of the number at the right side are greater. In comparing two negative numbers, the smaller the number, the greater the value. Here's the number line. From 0, here are the negative numbers. Negative 1 is greater than negative 2, and negative 2 is greater than negative 3. How about negative 100? This is greater than negative 125. Negative 125 is greater than negative 250. Let's try these given exercises. Write greater than, less than, or equal in each blank to make each expression true. Let's have example number 1. Positive 6 and positive 1. What do you think is greater? Correct. Positive 6 is greater than positive 1. Let's have example number 2. Negative 14 and negative 16. Which one is greater? Correct. Negative 14 is greater than negative 16. Now let's have example number 3.
1, and negative 10. Correct, 1, because that is positive. Example number 4. Negative 8 and 0. Which one is greater? Correct, 0 is greater. Let's proceed to example number 5. The absolute value of negative 1 and the absolute value of 1. Which one is greater? Yes, they are equal. They have the same value. What's new?
Integers, first-sign numbers. It belongs to the set of real number system. The set of integers includes counting numbers, and these are 1, 2, 3, 4, and so on. And then 0, and the negative or opposites of the counting numbers, which are negative 1, negative 2, negative 3, negative 4, and so on. Thus, if we are talking at the set of all integers, we may denote this using the following sets notation. All the numbers between negative 4 and all the numbers after 4. These are integers.
Here are some important things that we must remember about integers.
A number line can be used to show the set of integer. Here is a number line. The positive integer, positive 1, positive 2, positive 3, positive 4, and so on, are located at the right of the 0 on the number line. Here is a number line. At the right side are the positive numbers. And for the negative numbers, negative 1, negative 2, negative 3, negative 4, and so on, are located at the left of the 0 on the number line. Here is a number line. All the numbers at the left side of 0 is a negative number. 0 is neutral, which means that it is neither positive or negative. Here is the number line. The 0 is the origin. Take note, a number with no sign is positive, like 1, 9, 7, and even 100. These are positive numbers.
What is it? Lesson number 1. Absolute value of a number.
Let us consider the integer on the number line. How far is positive 3 away from 0? Now how about negative 3? Here is the number line. From 0, we have 1, 2, 3 steps to the right. So make it positive 3. And from 0, we have 1, 2, 3 to the left to make it negative. Based on the figure, both negative 3 and positive 3 are 3 units away from 0. Let's try this number line. Therefore, the absolute value of negative 3 is equals to 3. And the absolute value of positive 3 is equals also to 3.
Now let's have example number 1. What is the absolute value of negative 5? Correct, 5. This means that negative 5 is 5 units to the left of 0. Example number 2. What is the absolute value of positive 8? Correct, 8. This means that positive 8 is 8 units to the right of the 0. Example number 3. What is the absolute value of 8 plus 5? We have absolute value of 13. What will be our answer? Correct, 13. This means that 8 plus 5 is 13 units to the right of 0.
The absolute value of a number. This is the distance of a number from 0, also known as the origin. From 0, going to the left, 1, 2, 3 is negative 3. From 0, going to the right, 1, 2, 3 is positive 3. This is denoted by two vertical bars like this, or this one, or the absolute value of x.
Lesson number 2.1. Addition of integers.
In adding integers, we can use the number line or rule. Using the number line, however, has its limits. It can only be applied when the numbers to be added are small. The rules in adding integers can be applied to all numbers, whether they are small numbers or big numbers, using the number line.
Let's have example number 1. Find the sum of positive 2 and positive 3. Let's try this number line. Since 2 is positive, we move 2 units to the right of the origin. Adding positive 3 to positive 2 means that from positive 2, we continue to move 3 units to the right. If we do this, we will end up at positive 5. Hence, positive 2 and positive 3, the sum is positive 5. We may also write the answer simply as 5, since any number without a sign is indicated that the number is positive. What is our answer? Correct, positive 5. Let's have example number 2. What is negative 4 plus negative 2? Let's look at this number line. Since 4 is negative, we move 4 units to the left of the origin. Adding negative 2 and negative 4 means that we have to continue moving 2 units to the left. If we do this, we will end up at negative 6. Thus, negative 4 plus negative 2 is equals to negative 6. Our answer is correct, negative 6. Let's proceed to example number 3. Find the value of positive 5 plus negative 4. Now look at the number line. From the origin, we move 5 units to the right since 5 is positive. Adding negative 4 to 5 means that from 5, we have to move 4 units to the left and we end up at positive 1. Thus, 5 plus negative 4 is equals to positive 1, or 5 plus negative 4 is equals to 1. Our sum is correct, positive 1 or 1. Example number 4. Find the sum of negative 6 and positive 2. Look at the number line below. Since 6 is negative, we have to move 6 units to the left of the origin. Then, adding positive 2 indicates that we have to move 2 units to the right and we end up at negative 4. Thus, negative 6 plus 2 is equals to negative 4. What will be our answer? Correct, negative 4.
Look at example number 1 and 2. The question is, what can you say are like or similar. For question number 2, what did you notice about their respective sounds? My answer is we just add the addends with like or similar signs. Or very simple, positive plus positive equals to positive. Negative plus negative is equals to negative. Now, look at example number 3 and 4. The question is, how can you say about the signs of addends in each case? My answer is, the sign of the addends are unlike or the similar. Question number 2, what did you notice about the respective sums? My answer is, we just subtract the absolute value of the addends with unlike or similar sign. Very simple. Positive plus negative, we have positive because in my example, positive has the greater absolute value. Then positive plus negative is equals to negative. In my example, negative has the greater absolute value. Rules in adding integers. 2 ways. If we add 2 integers with like sign, add the absolute values of the 2 numbers and write the common sign before the sum. If we add 2 integers with different sign, subtract the absolute values of the 2 numbers and copy the sign of the number with the greater absolute value.
Example number 5. Susie receives 2 items in the mail. One is a check worth 3,000 pesos, while the other one is a house rental bill amounting to 5,000 pesos. How much is her net worth? For our solution, we will use the rule. Net worth is equals to check plus rental bill. For a number sentence, n is equals to 3,000 plus negative 5,000. N is equals to negative 2,000. What do you think is our sum? Correct, negative 2,000. Lesson 2.2, Subtraction of integers.
In subtracting integers, subtracting a second number from the first number is the same as adding the opposite or the additive inverse of the second number to the first.
Let's have example number 1. 6 minus 4 can be written as 6 plus negative 4, because negative 4 is the additive inverse of 4. Since both expressions are equal to, correct, 2. For our example number 2, 6 minus negative 4 can be written as 6 plus positive 4, because positive 4 is the additive inverse of negative 4. Both can be expressed as correct, 10. Example number 3. 6 minus 4 can be written as 6 plus negative 4, because negative 4 is the additive inverse of positive 4. Since both expressions are equal to, yes, negative 10. Let us consider some example using the number line. 5 minus 4 is the same as the expression 5 plus negative 4. Now, look at the number line. Using 5 plus negative 4 from 0 on the number line, we move 5 units to the right. Since we have to add negative 4, we then move 4 units to the left, and we end up at 1 on the number line. Thus, 5 plus negative 4 is equals to 1 or 5 minus 4 is equals to 1. Both of them are equal to 1. So our answer is, yes, 1. Let's have example number 2. Negative 5 minus 4 is the same as negative 5 plus negative 4. Again, let's use this number line. Using negative 5 plus negative 4, we move 5 units to the left of the 0. Since we have to add negative 4, then we continue to move 4 units to the left and we end up at negative 9. Thus, negative 5 plus negative 4 is equals to negative 9, or negative 5 minus 4 is equals to negative 9. Since both are equals to negative 9, the answer is negative 9. Example number 3. 5 minus negative 4 is the same as 5 plus positive 4. Let's use this number line. Using 5 plus positive 5, we move 5 units to the right of the 0 on the number line since 5 is positive. Then, adding positive 4 means that we continue to move 4 units to the right. Thus, 5 plus positive 5 is equals to 9, or 5 minus negative 4 is equals to 9. Since both are equal to 9, our final answer is 9.
If we take a closer look at the 3 examples, we will come up with the rule in subtracting 2 integers. Rules in subtracting integers. To subtract 2 integers, follow these simple steps. 1. Change the sign of the subtrahend or the number we subtract. Second one, proceed using the rules in addition.
For the next example, let us apply the rule in subtracting integers. Let's have example number 4. Before the lockdown, John borrowed 600 pesos from Paul to add to his weekly budget. During third week of lockdown, John worked as a gardener for his neighbor and earned 400 pesos. If he gave the amount he earned to Paul as partial payment for the amount he borrowed, how much more does he owe Paul? Let's try the solution. N is equals to negative 600 minus negative 400. N is equals to negative 600 plus positive 400, or its additive inverse, equals to negative 200. This indicates that John still owe Paul an amount of 200 pesos. Now, what do you think is our answer? Yes, the answer is negative 200 pesos. Lesson number 2.3. Multiplication of integers.
Multiplying integers. Multiplication can be expressed as a repeated addition. Suppose we multiply 3 by 2. In symbols, we write this as 3 times 2. Expressing 3 times 2 as a repeated addition, we have 3 times 2 is equals to 2 plus 2 plus 2 is equals to 6. We can illustrate this using a number 9.
Let's have example number 1. Look at the number line. 3 times 2 means 3 jumps of 2 units to the right. Starting from 0, the first jump of 2 units to the right lands on positive 2. From positive 2, the second jump of 2 units to the right lands on positive 4. The third jump of 2 units to the right lands on positive 6. Let's try example number 2. 3 times negative 2 is equals to negative 6. Using this number line, 3 times negative 2 means 3 jump of 2 units to the left. Starting from 0, the first jump of 2 units to the left lands on negative 2. From negative 2, the second jump of 2 units to the left lands on negative 4. The third jump of 2 units to the left lands on negative 6. Example number 3. Negative 3 times negative 2 is equals to positive 6. Again, let's use a number line. Starting with 3 times negative 2 means 3 jump of 2 units to the left. As explained in the example number 2, the 3 jumps of 2 units to the left will land on negative 6. The single arrow pointing to the left from 0 to negative 6 that was placed on the number line represents the complete 3 jumps of 2 units each to the left. Since was given originally was negative 3 times negative 2. Then, we will still need to consider the negative sign in negative 3. To account for the negative sign in negative 3, we flip the arrow horizontally by the origin. So, we end up landing on positive 6, which means that negative 3 times negative 2 is equals to positive 6. Or we can say that negative 3 times negative 2 is equals to 6. Carefully observe the previous examples. 3 times 2 is equals to 6. 3 times negative 2 is equals to negative 6. And negative 3 times negative 2 is equals to 6. This is our number line. What do you notice? These observations lead us to the rules in multiplying integers.
Rules in multiplying integers. If we multiply two integers with like signs, we multiply the absolute values of the factors or write a positive sign before the product. If we are multiplying two integers with different signs, we multiply the absolute values of the factors and write a negative sign before the product.
Now, let us apply the rule for the next example. Example number 4. During the quarantine period, Joanna planned to lose weight. She planned on losing 2 kilograms per week by exercising and eating a well-balanced diet. By the end of the 5th week, how much weight did Joanna lose? For our solution, we have n is equals to negative 2 times 5. N is equals to negative 10. This means that Joanna lost 10 kilograms in 5 weeks. Lesson 2.4. Division of integers.
In dividing integers, we check to see if the quotient is correct by multiplying the quotient by the divisor. Getting a product equal to the dividend means that the quotient we got is correct. To illustrate this, let us consider the following. To divide two numbers, we have dividend divided by the divisor, we have the quotient. To check if the quotient is correct, we have quotient multiplied by the divisor. The answer is the dividend. Starting with the multiplication statement we got earlier, by translating the rules in multiplying two integers in symbol, then we have the following. Positive multiplied by positive, the product is positive. Negative multiplied by negative, the product is positive. Positive multiplied by negative, the product is negative. And negative multiplied by positive, our product is negative.
We can use in that multiplication statement as a way to checking answers in division. Putting back these multiplication statements back into division statements, we have this table of multiplication statement to its corresponding division statement. It states that when we are multiplying or dividing same sign, our answer is positive. And if we are multiplying or dividing unlike sign, our answer is negative.
Rules in dividing integers. If we divide two integers with like sign, we divide their absolute values and write the positive sign before the quotient. If we divide two integers with different sign, we divide their absolute values and write the negative sign before the quotient.
Let's have example number 1. 10 divided by negative 5. What is our quotient? Yes, negative 2. Let's have example number 2. 12 divided by positive 3. What is our quotient? Yes, we have 4. 4 or positive 4. For example number 3, negative 24 divided by negative 8. Yes, we have 3 or positive 3. For our example number 4, negative 25 divided by 5, what is our quotient? Yes, we have negative 5. For example number 5, 18 divided by negative 3. What is our quotient? Yes, negative 6. For example number 6, we have 20 divided by 2. Give the quotient. Yes, we have 10 or positive 10.
Are you ready to answer your module? Good luck!
What's more? Independent activity number 1. Turn your module to pages 12 and 13. Using the number line, name the integer based on the given description. For letter B, find the absolute value of each number. Independent assessment number 1. Turn your module to page 13. Give the integer being described in each of the following. And for letter B, list the integers that can replace x to make a true statement. Independent activity number 2. Now turn your module to pages 13 and 14. Use any method to find the sum or difference. And for letter B, solve the following problems. Independent assessment number 2. Turn your module to page 14. Find the indicated sum or difference. And for letter B, solve the following problem. Independent activity number 3. Turn your module to pages 14 and 15. Find the product or quotient as the case may be. For letter B, problem solving. Independent assessment number 3. Turn your module to page 15. Find the value of n in each of the following. Letter B, problem solving. What I have learned. What I have learned. Turn your module to page 15. Fill in the blank by choosing the correct answer in the parentheses. What I can do. What I can do. Turn your module to page 16. Simplify each expression. Find your answer in the box below and write the corresponding letter before it. Assessment. Turn your module to pages 17 and 18. Let's try to answer our pretest. Choose the letter of the correct answer. Additional activity. For additional activity, turn your module to page 18. Use the following 5 integers to fill in the blanks in the box. You may use the same number more than once. References.
It's study time! It's time for you to answer your module. Thanks for watching. Good luck!